Good morning, everyone. My name is Mateo Estrada, and I'm an RU intern working with the GEM Lab. I'm a physics and computer science double major at OSU, and my mentors are Dr. Torres and Don Barlow, and we're looking at studying the impacts of earthquake activity on blue whale calling behavior using non-invasive acoustics. On the right is a picture of me, and on the left is a picture of a blue whale blow in Long Beach, California. Now, the blue whales that we're going to be studying are actually the blue whales that are actually from the South Taranaki Bight region, so that's the pygmy blue whales that are local to the STB region in New Zealand. And the question that we're looking to answer is, do blue whales have a specific behavioral response to acoustic disturbances in their natural environment? So, collecting over a 2-year period non-invasively, so with acoustics, 5 hydrophones were deployed and acoustic data was collected, and essentially what I will be doing is looking at that data. And so we formulated a hypothesis that pygmy blue whales alter their calling behavior as a response to earthquake activity. So some background. Well, these images, the one on the left shows a blue whale doing its famous blow, and on the right we have two whales, a mother and its calf, swimming. And blue whales produce a different number of callings, and so observations have shown that only males produce song, which serves their reproductive function. Now, downsweep vocalizations or decalls are produced by both sexes in a social context in association with foraging. And so, what does a decall actually sound like? Well, I'm going to be playing a recording of that to provide context. And this is what a decall sounds like. So, previous research on the effects of natural and anthropogenic noises on blue whale callings have taught us that sonar tends to decrease the number of decalls that blue whales produce. So, for example, the figure 2 here on the left shows a spectrogram, which is a graph that has frequency over time. And so, for example, when there's sonar signals, the number of decalls decreases or it even stops. And so what we're trying to do is to use earthquakes to figure out if they have an acoustic response in the decalls. So since we know that earthquakes and blue whale calls occur concurrently based on research that was done by Newkirk in 2004, which is another spectrogram that shows frequency over time, and it shows an earthquake and blue whale AB calls. These are a different type of blue whales, but nonetheless they show the concurrent events of earthquakes and blue whale calling. So we're gonna try to use our acoustic data to figure out if there's earthquake signals that we could use to test our hypothesis. Now, why earthquakes and decalls? Well, the South Taranaki Bight region, the STB region, as shown in this red circle, is a region in the Australian that is between the Australian and the Pacific plate, and therefore is very seismically active. There's over 23,000 earthquakes every year, and the earthquakes were seen in the acoustic data as shown in figure 4. These are 5 spectrograms. So a spectrogram has the frequency in the y-axis and the time in the x-axis, and there's 5, and so it shows the signal of an earthquake of a magnitude 5.7 and how it was captured. Now, how does an actual earthquake sound from the bottom of the ocean? I'm going to be playing the recording of an audio that I captured from the data, and an earthquake actually sounds like this. So what we're doing is that we're looking at the 6-month period deployment between January and June of 2016, and we're looking at the acoustic data from the hydrophones, so from these 5 hydrophones that were deployed, and that there's a lot of data there. So what we ended up doing was that we used GeoNet, and GeoNet is a database that has compiled data of seismic activity in New Zealand. of known earthquake events measured by a network of instruments designed to monitor seismic activity. And then we located earthquakes in our acoustic record using that GeoNet data. So what we ended up doing is collecting the magnitude, depth, origin time, public ID, latitude, longitude of the earthquakes. And there was about 3,000 earthquakes that were collected. So what I ended up doing was subsetting by magnitude, so any earthquakes that were greater than 3. And what we also ended up doing was we took an 8-hour window and we made sure that there was only one earthquake in that 8-hour window. And that was over the 6-month period. And that gave us about 1 earthquake per week, which yielded a number of 32 earthquakes in that subset. Now, the decall detection was a bit more involved because, like figure 6 right here is another spectrogram that shows in the black box, this black box right here, shows the signal of an earthquake. Now what we wanted to do is figure out how many decalls we could see 4 hours before this black box and 4 hours after. And we did this for a 4-hour window, 3-hour window, 2-hour window, and 1-hour window. And the results all looked the same for all 4 different time periods. And so my results are actually just for the 2-hour windows. And so this signal is actually for an earthquake of magnitude 5.7. And the yellow boxes are decalls. Now the figure 7 is a spectrogram with blue whale decalls that I manually selected. Some of them were selected using a detection algorithm, and then I manually went in and selected any that the algorithm had missed. And so important metrics that were measured from these decalls were the number of calls, the energy, the entropy, and the bandwidth. So these were the important metrics that were measured from these decalls. And we got a total of 27,000 decalls in our analysis, so about over 27,000 decalls. And now I'm going to show you guys the results. So the results show that there is no significant difference in calling before and after earthquakes. On the left, we're looking at the number of calls before and after each earthquake, connected by a line. No consistent pattern on the left. It just kind of looks like a spider web. And on the right, we can also see no difference in the mean number of calls before and after earthquakes, and the pair T test showed that there is no significant difference. Now this was for the number of calls, of decalls of before and after an earthquake. For the entropy, the energy, and the bandwidth before and after an earthquake, the results were essentially the same, so I'm only choosing to show this one. Now we also found that there is no change in the calling before and after earthquake events. In general, the change in all the call metrics was normally distributed and centered around 0 for entropy, energy, number of calls, and bandwidth. So we looked at the change in calling as a function of earthquake metrics, such as the magnitude, depth, distance to origin, energy, and we also included day of year to account for any seasonal effects and number of calls prior to the earthquake to incorporate blue whale calling context. We ran this for all the call metrics, so delta calls, delta entropy, delta energy, and delta bandwidth that we measured. And what we found was no significant relationship for energy, entropy, and bandwidth of the decalls. But we did find that there was a significant relationship between the change in the number of calls and the number of calls prior to an earthquake. And we ended up looking more into that relationship. So impact of calling context matters. It seems right here that on this figure, the change in the number of calls increases with the number of calls before an earthquake. And we wanted to examine that relationship more closely because we can see that if there are more calls in the period prior, there will be a higher probability for a change in the number of calls. While this is a significant relationship, we also wanted to see if this holds true with no earthquake activity. Therefore, we selected a null period of 4 hours where there was no earthquake, split it into two 2-hour periods, which we treated as before and after a null event. So 4 hours, null event, so that means no earthquake, and we split it into 2 hours, 2 hours, null event in between. We wanted to see if the calling context also mattered, even if there's no earthquake. And what we found was that the same relationship showed. So that means that when there are more calls before, there is a bigger change, even in a null case where there is no earthquake. So this is independent of the earthquakes. So, back to our question, do blue whales respond acoustically to earthquake activity in the ocean? Well, it seems that blue whales show no acoustic response to earthquakes in central New Zealand. Possible reasons why no response? Well, evidence shows the STB region is home to the pygmy blue whales year-round, so they're there year-round, and every year there's about 23,000 earthquakes in that region, so it could be that they're just used to it. Further research could shed light on this, so researching if there is any relationship between earthquakes that are of magnitude greater of 5 and above could shed some light on this matter more thoroughly. Also analyzing the effects of blue whale song. So since blue whale song is slightly different than decalls, there might be some difference there. But yeah, I just want to acknowledge my mentors, the GEM Lab, the interns, Chung for putting this internship together. My previous mentor, Dr. Lester Morales and Lila Magdaleno, for helping me with letters of recommendation. Thanks to the Hatfield Marine Science Center and the National Science Foundation. And thank you for your... Well, and that's it. Any questions or comments? Also, my contact info is right here, so if you want to shoot me an email, you're more than welcome to. But thank you very much for your time.